The head secured. Well, why is the head secured? It doesn't say. It just says the head secured. Well, I'll tell you why the head's secured. Because this is the head on the barge, and it's serviced by a marine sanitation device. And the blower has died. This blower serves an important purpose into the proper functioning of a marine sanitation device. Without the blower, we don't introduce air into the sediment chamber and clarifying chamber, which oxygenates that water. That dissolved oxygen content is important to the survivability of the enzymes. Without the enzymes, the human waste and the paper doesn't get broken down appropriately, and it causes a malfunction and clogs up my marine sanitation device and just kind of turns it into a septic tank.
Do not go in there. Woo!
Well, before I start the job, I want to unbox this thing, this new blower, so I can see what I'm dealing with here. It's in there all right. A lot easier to do on the deck. So I got a blower. See what else is in the box here. Nothing. Instructions. Who needs that? So it looks like it's kind of bolted to a cardboard base here. But what I'm looking at is I got the business end. This is the blower. My electrical connection box, I'll be going in there for my electrical connection, just like the existing one has. And down here, I've got two fittings. It even says out. So that's going out to the blower. And this is coming in because that's where the air is coming in from. So it does not come with all the attachments that are currently installed on the marine sanitation device, on the existing blower. So we're going to have to recoup those things and use them on this installation. Inside the control panel for the marine sanitation device, we will find a couple of items in here. Obviously this is electrical circuitry, so there's live circuitry in here. I've got two toggle switches in here. Both toggle switches have three positions: off, auto, and test for the pump. Or hand for the blower, or auto for the blower. Right now I have the blower toggle switch in the off position because the blower has died. So normally the blower toggle switch would be in the automatic position, and the blower would come on and go off throughout a 24-hour period based on the timing that's factory set on this timer right here. So in a 24-hour period, this blower will function in an on and off mode to supply enough dissolved oxygen to the marine sanitation device sediment and clarifier chambers, keeping those enzymes happy. So since the blower has died, I'm going to have to mechanically and electrically disconnect the blower from the MSD before I can replace it with the new blower. So one of these three breakers controls the power to the blower. Even though the toggle switch is in the off position, I would like to open the appropriate breaker and lock it out and tag it out so I can safely disconnect and connect the new blower. So that information is right here in the control panel door on the schematic for the blower. It tells me that this breaker right here is the breaker for the blower. So if I de-energize it, I can op test it real quick by trying to go to hand mode. I get nothing. I get nothing. This is for the pump and the timer. Now, how do I know my voltage detector works? Well, it says right on here, test on known live circuit before each use. So I know there's a live circuit right here, and that's the indication I would expect from a live circuit. Now, if we go over to the motor, you'll see we don't have any live circuitry going to the motor. So once I've got the circuit breaker locked out, I'm going to double check with my voltage detector to make sure I have no live voltage at the cable going to the blower motor, and I do not. Okay, we've got our electrical disconnect complete, so we've got no electrical circuitry active for the blower, and now it's time to physically remove the blower from its foundation. But before you start something like that, you just want to do a survey of what tools you need. You might need some PPE, you might need some tools, and it's more efficient to collect all the appropriate tools and PPE ahead of time as opposed to walking around and taking an hour to find a 9/16 inch combination wrench and a socket, or a spade tip screwdriver to remove the hose clamp and open up the electrical connection box. So it's a good time to get that stuff together ahead of time and then come back, and it makes your disassembly go much faster. So I've gathered all my tools. I've got something to put all the fasteners in and spare parts so I don't lose them. Got my cordless screwdriver I'm going to use this small socket set with to remove some of the smaller components. And I got my ratchet with a socket and my combination wrench, along with a screwdriver. Now I'm ready to go to work. Damn, that took forever. So now that we've got the old blower removed, we're going to take the reusable parts off the old blower and put them on the new blower. So let's get to it.
Well, we had a little bit of a setback. When I was attempting to reinstall the intake piping through the filter into the blower, I came in contact with the housing for the blower motor. Apparently this blower motor is a little bit bigger than the previous blower motor. So now what? Well, I've got a street elbow here. All I have to do is add a coupling and a nipple, which I will put anti-seize tape on before I actually install it. This white tape, it's designed to prevent seizing. So disassembly is a lot easier if you put this on. A lot of people think you put this on the threads to stop leaks or to prevent leaks. That's not what it's for. So don't do that. Don't think that. If you got leaks, then something ain't put together right, all right? So once I put the coupling on, I'll put the anti-seize tape on the nipple, install the nipple, then I've got plenty of clearance to clear the motor. I've got no issues on this side of the blower when it's installed. So I'm good to go there. And I would just like to thank England Marine, your local fishing and hardware store at 95 Hamburg Street, for the stainless steel coupling and the stainless steel nipple. It was only $21.95 for the set. Now, the reason I'm using stainless steel is because I've got a stainless steel street elbow and another stainless steel nipple and another stainless steel coupling going to the housing that holds the filter and the cap for the filter element. All stainless steel. You wouldn't want to use some ferrous metal, stainless steel, copper, aluminum, galvanized, all dissimilar metals. They have chemical reactions and they fight each other. And there's a problem with that. So we'll cover that, the dissimilar metals, using dissimilar metals and why you don't do that in a separate production video. So we're going to go back to assembly now.
So before we take this back into the sewage treatment room and bolt it down and wire it up, I got a problem here. I've only got 3 wires in the sewage treatment room, but 6 coming out of this electrical connection box. Sometimes a motor will have the diagram on the housing, and sometimes they hide it. And they tell you what to do with all those colors. It gives you 2 options. So this particular motor can run off high voltage or low voltage. We're using low voltage. We're using 115 to 120 volts. So that would count as low voltage. We're not using high voltage. So in this case, what we're going to do is connect the brown, the black, and the orange together. So they'll all be connected together. Line 1, we'll use the blue line. Line 2, the white and the yellow. We'll have to do the rest when we get back to the sewage treatment room. And it also gives you an indicator of counterclockwise direction when looking at it from the drive end, which would be this end. So conveniently tucked away inside the control panel for the MSD, the electrical schematic is available, which is where it's going to go when I'm done. So you can see the blower, the pump. This is coming from the main feed lines, and it says line 1, which happens to be the black one, and line 2, I don't know if you can see that, was the red one. So making the connection to the motor is going to be easy because it's clearly identified in the electrical schematic. If I didn't have the electrical schematic, I'd have to do some testing. But in this case, it was available, and when I get done, it's going to go right back in there. So if the next guy has to do something like maybe replace a pump or another blower down the road, we have the information that we need. So all the electrical connections are complete now. Did all the wiring inside, connected the ground screw to the casing, and everything's nice and tidy right here. Now one thing is, this fitting right here, kind of looks like this one right here, it's for wet environment. So the cable goes through here, moisture won't go all the way through. This is what you're seeing on the outside, and then on the inside of the electrical connection box is this guy right here, and they are really a pain in the butt to get on in this confined space, which is why I chose to do the wiring before I bolted the unit down so I could tip it up and get my fingers in there, because sometimes getting in these small places and trying to get that nut started, you got wires coming out of it, and so you don't have a lot of clearance in there to do that. It's kind of like working on a fine switch watch with a baseball mitt on. But anyway, got that done. That took the longest, I think, of the whole thing, and then getting the ground screw started. I had to go get the cordless screwdriver to get it started in the housing because there's never been a screw in there yet. So that's all good to go. The electrical's done, and I'm ready to move on to the next phase. I'm going to go ahead and reinstall the filter. Now, the filter, even though it's probably got a few more months of life in it, I've got a brand new filter. So, putting on a new filter. The housing back on there. You notice the wing nut was still here. I left it on there after disassembly. There's no reason to put it somewhere. I mean, if I can screw it back on to where it was, I know it's going to be there when it comes time to put it back together. So now I'm going to get my fasteners here and bolt her down to the foundation. Now I want you. So now I'm ready to bolt this down to the foundation. So I've got my fasteners right here, got all 4 of them because I kept them in my can with all my parts. So I've got a washer on the top that you'll see visible, and then a washer on the bottom with a lock washer and the nut, and that'll secure it to the foundation. Now this is the way you want to bolt it up. You want the nut and the lock washer on the bottom, because if you install it this way, which in some cases might be easier to do, it's not a good engineering practice, because if over time this starts vibrating and this starts getting loose, and what's going to happen is your nut falls, your fastener falls off, and you're left with a nut dangling here. So you always want to do it this way. That way, if the nut does fall off for some reason, let's say you didn't tighten it up enough and the nut does fall off, your fastener's still in place. So we're going to go ahead and bolt this down. Okay, we've got the 4 fasteners in place, nice and secure. It's always a good idea to put your fasteners in place first, hand tight everything, make sure everything's hand tight, because you may have to move things around, you might have to shim something.
In this case, we're not worried about alignment issues with another device. We're just going to have a hose here. If we were driving something with a motor or a pump or something, we'd have to align those two components up so there's no misalignment and damage to the equipment. So in this case, 4 fasteners hold us onto this aluminum base. There's really no torque value because it's not that big of a deal right here. So just snug. You don't want to over tighten them and snap the fasteners off, because it's probably one of those things where you don't have a spare. Then you got to go back to England Marine. So we've got everything bolted down. We're going to op test the motor before we make the connection. Okay, so I've cleared the lockout tag out, energized the breaker inside the power panel, and I'm going to toggle the blower from automatic mode to hand mode. In the automatic mode, the blower runs off of a timer that's preset by the factory based on the size of the unit. So when I energize or toggle the switch up, I expect it to rotate in this direction because I'm blowing air out of this fitting and bringing fresh air in through the filter. Ramping up the speed. Got a lot of good airflow out of there. Now at this point, I'm ready to hook the hose back up, which goes into the MSD. But I've got a bit of a problem. When I was disassembling or removing the old unit, there was liquid in here. So in this case, this area down here where the air is accumulating and blowing out, there was liquid in there coming from the MSD. So that's a problem. That check valve right there must not be working, because the check valve is supposed to allow flow in one direction only. And based on this pivot point right here, means the flow direction is going into the MSD. If it's working properly, liquids won't come out of the MSD. And the actual fitting is above the water line. The normal water line for the MSD is right about there. Because if it gets any higher than there, it spills across the chlorine tablets and goes into the chlorine contact chain. So before I hook up that hose, I'm going to open and inspect that check valve. Well, I tried to use a pipe wrench, pop that cap off, and it's on there so damn tight, I don't want to crack the plastic case, because then I'm at a point of no return there. So what I did was I took a screwdriver, went in there and manipulated that disc in there several times, and it does open and close. So there might have been something just stuck in there a little bit that was causing a little bit of backflow when the blower was not in operation, but it looks all clear now. So I'm going to put the hose back on and clamp it down, and since I'm in an environment where a little bit of soap's not going to hurt anything, I'm just going to lube up this fitting, and it makes sliding that hose on there a lot easier. You always want to make sure that your hose clamps are there before you put it on, because once you put it on and you left your hose clamps in your can or your bucket, guess what? You got to take them off. So a little bit of Dawn dish soap, that thing slides right on there like butter. You're lined up. This has to be snug. We'll lube up the other side and hook that up as well. And I just want to highlight the fact that at this point in the evolution, I am wearing PPE because there's a potential for bloodborne pathogens in the liquid that's inside the sediment and clarifier chamber of the MSD. Once it goes through the chlorine contact tank, it's a whole different story. But right here, there's always that possibility. So I always want to have PPE on. I'm going to go ahead and hook up the other side, and then we'll place it back in operation.
So now we're operating in the hand mode. If I go to auto, the blower's in auto now because it's functioning off the timer. So the timer's active right at this point in time. And like I said earlier, this timer is set by the factory based on the size of your MSD. Obviously, the bigger the MSD, the longer the blower is running in a 24-hour period. The Ironwood has the largest MSD in the vocation right now, so that blower spends a lot more time operating than the other two. So now my enzymes that are rolling around inside the MSD, they're getting some fresh air. And they're happy. And that means they're probably getting hungry. So I'll have to talk to somebody to help us out with that. We'll also go ahead and treat the MSD with some fresh enzymes to kind of boost them up since it's been down for a little bit of time. And you'd think at this point my work's done. But I got a lot of tools to clean up, a lot of tools to put away, and I also want to, well, that's it. Put all my tools away.
So we finished the blower replacement project on the barge for our MSD. This is the old blower, the one that died. Right? I'm going to put this in the box, let the new blower came in, makes it easier to carry out of here, take it up on the pier and open and inspect it. When it died, I had that familiar smell of electrical wires burning. I don't know if you've ever smelled that. If you have, you know what I'm talking about. If you haven't smelled that, you just haven't smelled it yet. So what I suspect is it was an electrical failure. What I was told by an old man one time was that when they make motors, when motors are born, they put a secret package of smoke in there inside the motor. But if that smoke gets out, then the motor's dead. So we're going to open it up and see if I can find this secret pack of smoke that might be in here. It's worth a try. It's not really worth rebuilding this kind of a unit. It's not cost effective. Parts, labor, all that. Then you're still left with a refurbished device. It's better, in this case, replace the whole unit. It comes straight from the factory in a nice cardboard box. It's pretty much plug and play. So I'm going to open and inspect this old dead blower, and I think I'm going to have to use some percussion engineering to get it open. So this is the only tool I'm going to use today, but I want to think about PPE because if I'm using percussion engineering, I'm probably going to be making some noise. Now, I got a couple options here to protect my hearing. I can either use earmuffs or earplugs. Now, in accordance with the Tongue Point Job Corps SOP 5 TAC 14 TAC 15, decibel levels above 85 will require single hearing protection with a noise reduction rating of 32 decibels. Now, these particular earplugs that we use around here quite frequently by this manufacturer clearly state that the NRR, or noise reduction rating, is 32. So if I'm making noise above 85 and I take 32 away, well, I'm below the 85 threshold. Double hearing protection is going to be required if I'm making peak noises above 106 decibels. I'm going to wear earplugs and earmuffs. Now, that's something you need to think about when you're banging on stuff, is the peak noise. Now, the actual noise, pretty loud, right? Normal conversation around 60 to 65 decibels. Unless you're Boats Lynette, then you probably need single hearing protection. Just saying, if you want to protect your hearing for the future. The Tongue Point Job Corps SOP has all this stuff listed in there. Some peak noises around the center. There's a noise survey that's available so you can identify what items around the vocation that produce noises and what their decibel levels are. And that's just specific to this Job Corps center right here. But at your job site, you can rely on their specific SOPs, or if you're not quite sure, you can look it up in the Code of Federal Regulations 1910.95. It spells it all out. As a matter of fact, excuse me, the Job Corps' SOP is pretty much verbatim what's in the Code of Federal Regulations 1910 TAP 95. Now, I'm also going to be requiring some other PPE besides my earplugs. Safety glasses, because like I said, I'm going to be doing some percussion engineering. So I've got safety glasses that don't quite fit over my regular glasses. So as an extra measure of precaution, I'm going to use this face shield because I don't want to damage any of this. So I'll get my blower up here, we'll get my PPE on, we'll take a look at what's inside. That's one tough blower. Yeah, just like I thought. That pack of smoke that was in there when they built it, it ain't in there no more. It's dead.
This video brought to you by Rigid. See their complete line of battery-operated tools at rigidtools.com. And by Lysol Disinfectant Spray. Eliminates odors, has a crisp linen scent, and kills 99.9% of viruses and bacteria. Dawn Dishwashing Liquid, a fine lubricant. And with over a century of coffee brewing history, Lavazza, Italy's favorite coffee. Try the Premium House Blend. It's a new blend.